Hello, welcome back students. Hi students, how are you? Hope all are doing fine. Now students, we are on the functions, topic functions. This is a part 2 of the video for the topic functions. Okay, we are in chapter 8, topic functions. Now students, we'll just have a review on functions. Okay, now last class I revised to you what are functions. What was function? What's a function, students? It's a special relationship where each input has a single output. Okay, that is, this idea of function is used almost in every branch of mathematics, and we discussed about the common notations also, right? And it's often written as f of x, where x is the input value, and this x is the input value and f is the function name. Okay, this function name can be any other alphabet also, not necessary to be f. Okay, now students, then functions can be illustrated by flow diagram, right? So that also we discussed in the last class. So what is flow diagram? It's a diagrammatic representation of what? Of a set of instructions which has to be followed. Now flow diagrams are made up of what? Different boxes, and each box has different functions. That is, flow diagram consists of functions consist of simpler functions, and that is illustrated by a flow diagram. Okay, so now we will move on to our topic for the day. Our topic for the day is composite functions. So today in this video we'll discuss about, I'll introduce to you two topics, that is two subtopics actually, that is composite functions and inverse functions. Actually this composite function and inverse function is also very easy. Hope all of you have practiced your assignment questions and practice all the questions shown in the last video. So now moving on to composite functions. What are composite functions? Okay, see, composite means it's a composition of functions. That is, a composite function is a function that depends on another function. Okay, that is, a composite function means, see, some functions, it's the functions, for instance, for example, f of x, okay, is equals to 3x plus 2, for instance. That itself is a composite function because it consists of simpler functions. That is, 3x multiplied by 3 and add 2. Okay, that is the simpler functions for 3x plus 2. Now your composite function is created when one function is substituted into another function. For example, f of g of x. Okay, I will put an illustration and an example to you. That is, here you understand the fact that is, composite function is created when one function is substituted into another function. That means it consists of one or two or more similar functions. See, for example, f of g of x is a composite function. Okay, previous we were learning about f of x. Okay, now we are dealing with f of g of x. So f of g of x is a composite function, and what is it? That is found when g of x, this g of x, is substituted for x in f of x. Okay, so now g of x is going to be substituted in f of x. So f of g of x is read as f of g of x. That's how you read it. Okay, so composite function, this is an example of composite function, and that is formed when g of x is substituted for for x in f of x. Okay, so composite function is a function that depends on another function. It is created when one function is substituted into another function. Here, g of x is substituted for x in f of x. That is what I said. Composite function is created when one function is substituted into another function. Okay. Now, composite functions are here f of g of x. You can write it in this form also, but this is a common format, f of g of x. Okay, that's the common form. Now we will see the steps for evaluating composite functions. Okay, start with the inside function first. So the step for evaluating composite function is, here this is f of g of x. It's a composite function. Okay, now how you evaluate this? Evaluate g of x first. Okay, first evaluate g of x. Okay, then that is start with the inside function. Inside function, whatever is the inside function, start with this. Here in this case the inside function is g of x, so start with g of x. Now after that, use the result. You when you evaluate g of x, you get a result, right? Use that result as an input for the outside function, right? Okay, first evaluate g of x, and the result you get for g of x, use that result as input for f of x. Okay, so that is what I mentioned here. Evaluate g of x in f of x. Okay, so use the result as input for the outside function. Here the outside function is f of x. So that is the steps for evaluating composite function. First evaluate g of x, and then use the result of the inside function to evaluate, in this case, f of x. Okay, now I will illustrate to you two functions. Okay, that is f of g of x. F of g of x means it just consists of two or more simpler functions, right? Now here I've given two functions. That is, first function is f of x is equals to 3x plus 2, and g of x is equals to x squared. Okay, these are the two functions. Now students, okay, so f of g of x means what? That is a composite function. Okay, where g is performed first. G of x is performed first, and then f is performed on the result of g. The function f of g may be found using a flow diagram. Okay, now the function fg can also be found using a flow diagram. Okay, so what the function here fx, if f of x is equal to 3x plus 2 and g of x is equals to x squared, then f of g of x is a composite function where g is performed first and then f is performed on the result of g. So now the function is going to be illustrated. I'll illustrate with the flow diagram. Okay, so flow diagram, it is represented using boxes. So now x, okay, x and the square of x. Okay, the square of x, here it is g of, first what you do is you have to, g of x is performed first, right? So here in this g of x it is x squared, so square the x, then what you do is multiply by 3. Multiply by 3, so you will get what? 3x squared, right? I'll repeat. You are going to f of g of x is a composite function, and how you evaluate it is you perform g is performed first. That is what we are doing it. Okay, g of x is equals to x squared, so you are squaring the x, okay, to get x squared. Then next step is you multiply by 3 because you are going to evaluate g of x. This is the input for f of x. Okay, so multiply by 3 to get 3x squared. Now the next simpler function is add 2. So you added 2 to get 3x plus 2. See, 3x squared plus 2. Here 3x squared plus 2. So f of g of x, how can you write f of g of x? F of g of x is equals to 3x squared. So this is our function g. Okay, this is our function g and this is our function f. So f of g of x is equals to 3x squared plus 2. Okay, so this is how you represent, illustrate f of g of x, a composite function f of g of x with a flow diagram. Okay, so composite functions, this function itself consists of simpler functions. Okay, f of x, here it consists of two simpler functions, right? What are the two simpler functions? Multiply by 3 and add 2. That's the two simpler functions consist here for this function function f of x. Okay, now for this composite function, I told you how you perform is, you perform g is performed first and then f is performed on the result of g. Okay, here that's how you illustrate with the flow diagram. Now students, here composite function, we will composite function is created, I told you already, when one function is substituted into another function. Here I have given an example question. The question is given f of x is 3x plus 2 and g of x is x plus 5. Okay, I have given two functions. Now the question is you have to find f of g of x. Okay, to find f of g of x, what you should do is g is performed first and then f is performed on the result of g. Okay, so that is what I have written, f of g of x. That means what is our input? G of x. So g of x is equals to x plus 5. So this is our input in our function f of x. Okay, so our function f of x is 3x plus 2. So you are going to input this x plus 5 in or you are going to substitute x plus 5 in place of x. So how can I rewrite this as? I can rewrite it as 3 in this place of x. I am going to substitute our input x plus 5 plus 2. Okay, so that's how you go find out f of g of x. Okay, so I'll repeat once more the step. F of g of x means g is performed first and then f is performed on the result. So here our question, as per the question, f of x is 3x plus 2 and g of x is x plus 5. So f of g of x means the input here g of x, x plus, that is which is equals to x plus 5, will be substituted for f of x. Okay, so here x value, this x will be replaced by g of x. So what will be, instead of this x, you will write x plus 5, that is g of x. So now you will simplify it. Simplification part, you know. First simplify what is in the bracket. So you will get 3x plus 15. 3 5 15. I multiplied it. Okay. Remove the bracket. 3 multiplied by x plus 3 multiplied by 5 to get 3x plus 15. Now group the like terms and add 3x plus 17. So this is f of g of x. That's how you get f of g of x. Okay, students. Now another, for this itself, another I will find g of f of x. Okay, see, first we found f of g of x. Now we're going to find g of f of x. Now what you do is, you here f of x is performed first. Function f is performed first and then g is performed and then f is performed on the and then g is performed on the result of f, function f. Okay, so g of f of x is equals to, here f of x is what is f of x? 3x plus 2. So you are going here and our g of x is x plus 5. So you are going to substitute this x by our f of x. So g of x is x plus 5. So in place of in place of this x, you are going to substitute 3x plus 2. Okay, so g of 3x plus 2, because f of x is 3x plus 2. That's why I wrote here g of 3x plus 2. Going to substitute, that is, in place of x, since g of x is x plus 5, here 3x plus 2 I have substituted instead of x to get 3x plus 2 the whole plus 5. Okay, got it. Now simplify what is in the bracket. Now students, I'll speak to you about inverse functions. So what is inverse function? Okay, inverse means just it is just the reverse of. Inverse function goes the other way, that is it's just the opposite way. That is the inverse is usually shown by putting a little negative one after the function name, like this. I'll show you here. This is f inverse of y. Okay, how you read it is f inverse of y. Okay, so now that's how you read. We say just f inverse of y. Okay, so the inverse of f of x is equals to 2x plus 3 is written. We'll see how the inverse of this function. Okay, the function f of x is equals to 2x plus 3. The inverse of f of x will be written as, see, that is what you do is you will go the other way. That is all. Here it is positive 3, it becomes negative 3, and here it is multiplication changes into the whole division. That is what the inverse of the function of f. A function, inverse function means it goes the other way or in the other opposite way. I'll show that in detail. I will explain to you how you got this in detail. Okay, so you know how to write it, right? It's written with by putting a little negative one after the function name, okay, here the function is f. If it was g, it will be after g, after the function name you will write it. And here how you read this is, if you say f inverse of y. Now we can find an inverse by reversing the flow diagram. See students, you have I'll introduce to you two methods to find inverse functions. Okay, one is the flow diagram and the other method is the algebra method. That is algebra method is comparatively easy and it is better, it is easier for when you have difficult questions. Okay, so many people prefer the algebraic method. Okay, so the algebra method you will also find it easier. Okay, now students, we can find inverse by how? By reversing a flow diagram. You already know how you draw a flow diagram, right? Not only that, we can find an inverse by using algebra. So these are the two methods I will discuss today. That is flow diagram, by flow diagram, that is by reversing the flow diagram. That's how you get inverse function. Okay, and also by using the algebraic method. So here in this algebra method, speaking about the algebra method for inverse functions, in short what you do is the f of x, right? Function f of x, for instance, function f of x. What you do is you replace the function f of x by the variable y. Okay, and then you solve for x just like you solve other equations. That's out in just, okay, but I'll show you in detail with an example. So now we will see inverse functions. Now first I'll demonstrate to you, illustrate to you inverse functions with a flow diagram. Now consider the function f of x is equals to 5x minus 2 divided by 3. This is the function. Now the inverse function of this I'll show you. First I will show you a flow diagram for this function. Okay, the flow diagram for this function I'll illustrate to you. After that we will draw the flow diagram in the opposite way. Okay, with each operation replaced by its inverse. Okay, that is, first now for this function, here I have given a function f of x is equal to 5x minus 2 the whole divided by 3. Now I am going to represent this function by, or illustrate this function by a flow diagram for function f. Okay, after that to get the inverse, okay, what I will do is you will draw a net flow diagram. We will draw a net flow diagram with each operation, okay, with each operation replaced by its inverse. Okay, with each operation replaced by its inverse. So we'll start with the flow diagram. Here, the flow diagram, as per the flow diagram, what you have to do is the x, you have to multiply by 5, right, to get 5x. Multiply by 5 to get 5x. Then the next function is you have to uh, subtract 2. That is the next mathematical operation, subtract 2 to get 5x minus 2. Then the next mathematical operation to be done as per the function is the whole divided by 3 to get the function f. So the flow diagram for f will be 5 here is now done. That is, we got 5x minus 2 the whole divided by 3. So now that's how you draw the flow diagram for the function f of x. Now we will consider a net flow diagram in reverse. That is, you will start from right and go left. Okay. That means your arrows also will point likewise. Here you see the direction of the arrow. When you go in the reverse direction, your arrows also will be in the reverse direction. Okay, or the opposite direction. So you will start from the right and go left. Let us start with x on the right. You will start with x on the right. Okay, so here in this net flow diagram, what you're going to do is you will reverse flow in reverse order. That is, you will reverse the flow diagram with each operation by its inverse. So, and I told you, you will start with x on the right. That is, start from the right and go left. So we will start with x on the right side. See, I will start with x on the right. Okay, we'll start with x on the right. So I told you previously, with each operation we are going to draw the net flow diagram with each operation replaced by its inverse. So now divide by 3 will be replaced by its inverse of multiply by 3. Okay, so multiply by 3, you will get what? When x is multiplied by 3, you will get 3x. The next operation is, here in our flow diagram, the next operation is subtract 2, right? Okay, so to get the inverse function, what you do is you replace it with its inverse. So what you do here, you have subtracted 2. So its inverse operation is going to be you add to it. So you will get 3x plus 2. Okay, when you add 2 to 3x, you will get 3x plus 2. Now the next operation is, here it was multiply by 5. So you will have to do the next reverse operation, that is divide by 5. So you will get 3x plus 2 the whole divided by 5. And see the arrows, students, and see from where we started. Start from the right and go left. That is, start with x on the right. Okay, and each operation will take its inverse function. Divide by 3 became multiply by 3 to get the inverse function. Subtract 2 for in the inverse function. To get the inverse function, we added 2. Okay, so now our inverse function is, see, 3x plus 2 the whole divided by 5. Here we have already written here 3x plus 2 the whole divided by 5. That is the inverse function. So for what we do is, the inverse of x, the inverse of f is given by 3x plus 2 the whole divided by 5. Now we will see to the inverse function by using the algebra method. We'll solve using the algebra method. That's the second method. Okay, yeah, I previously gave you a gist of it. That is, just in the previous slide I gave you a gist of it. That is what you do is you put y or replace f of x with y, with the variable y, and solve for x. That's in a gist. I will illustrate to you. Okay, now the function f of x is equals to 2x plus 3. That's the function. Now, as per this algebra method, what you do is you put y for f of x. Okay, put y for f of x. So I'm going to rewrite it as y is equals to 2x plus 3. Okay, how we got this equation? We got this equation because I replaced this function f of x by the variable y. This is the algebra method for to find inverse function. Okay. The next step is you have to solve for x, right? So what you do is you rearrange the equation to make x the subject. So I'll make x the subject by transposing positive 3 became negative 3, and then you make x the subject, so it will be y minus 3 the whole divided by 2. That is, I just flipped here, so my flipped the equation and I brought it here, x here. Okay, so x is equal to y minus 3 the whole divided by 2. So now we got here x is equals to y minus 3 the whole divided by 2. So now what is our inverse, students? So solution, now our solution is going to be, just put the f inverse of y. Okay, just put f inverse of y for x. Here you will replace this x by f inverse of y. So our inverse function is f inverse of y is equals to y minus 3 the whole divided by 2. Okay, that is this x, you just replace it with f inverse of y to get the inverse function. So this is damn easy, right? So algebra method is very easy, and it's many people prefer this method. But if you ask to illustrate with a flow diagram, you should be familiar with it. That is why I illustrated to you with the net flow diagram also. Okay. Okay, students. Now, so this method works very well for difficult inverses. That is, you use this method to when you prefer to. This method is preferred by many because this is more easier. You find it more easier. Now, students, we'll go to exercise 12. We will move on to exercise 12. Students, please take out your textbook, page 284. We are in exercise 12 now. Okay, functions. The function I'll give you, we are going to deal with question number. I'll write the question for you. Here the function f, g and h, okay, are as follows. Okay, now the function f of x is equals to 2x, and g of x is x minus 3, and h of x is x squared. This is the question given to you. Now we are going to evaluate question number 4. Question number 4 says evaluate. So for subsection C part is g of h is equal g of h of negative 3. That's our question. Okay, so we will evaluate that question, g of h of negative 3. Now, given here it is given to us, right? G of x is x minus 3 and h of x is x squared. Here you have the function g of h is negative 3. G of h of negative 3. So here it is, this function is given to us, that is h of x is x squared. So what you do is, here h of x is x squared, right? So what is our input given here? I told you previous video, what is given in bracket is our input operation. Okay, so here x squared, h of x is x squared. So our x squared, h of x is x squared. So this x squared will be substituted by this input of function input, that is negative 3. So what you get is negative 3x the whole squared is going to be 9. Okay, now you got h of x, h of negative 3. What is h of negative 3 is 9. Okay, so now you will use this input. This is the input for g of h of negative 3. This is a composite function, students. Okay, this is composite function. Last class we were not dealing with composite functions. See, here we have to g of h of negative 3. So first we find, I told you in the previous slide, first you will find g of h of 3, and then you will first h is performed, and then g is this g is performed on the result of h. That's how that's the sequence of composite functions. Okay, now here we first performed h of negative 3 to get 9. Now we will perform g of h of negative 3. So g of h of negative 3 means to find g of h of negative 3. Your g of x is x minus 3, right? G of x is x minus 3. Okay, so g of h of negative 3 is your this function x. Okay, your h of 3 is what? 9. So g of 9 is going to be, you know from where I got this x minus 3, right? Because g of x is x minus 3. So g of 9, from where I got this 9, that is our input for h of negative 3. Okay, so g of 9 is going to be is equals to x minus 3. So now we are going to input a 9 in place of x. Okay, so 9 minus 3, you will get 6. That's so your answer for g of h of negative 3 is 6. That's your answer, final answer. Okay, so how you perform this composite function operation is, first your h of negative 3 is performed, and then you will use this input as to evaluate g of h of negative 3. Okay, so this is our final output. Now students, we'll move on to next question, the same exercise, exercise 12, question number 8. The function, please open your textbook. Hope all are having a textbook open, page 284. Okay, the question is, function L, M and N are as follows. See, this is a function L of x is 2x plus 1 and M of x is 3x minus 1. And now what you need to find is, find A, first part. Okay, find A part, x if L of x is equals to M of x. See, I'll read the question. Function L and M are as follows. Find A part of question number 8. X. Okay, find x if L of x is equals to M of x. That means L of x, this function and this function, they have given here as equal. L of x is equals to M of x. So how you solve it is just you substitute the values given. L of x is what? 2x plus 1 and M of x is 3x minus 1. You will just substitute to find x. What you do is, if L of x is equals to M of x, from where you got this is already given to you. If L of x is equals to M of x, so you substitute the given values. 2x plus 1 is equals to 3x minus 1, because L of x is 2x plus 1. So you can substitute it as with this L of x is 2x plus 1 and this M of x is 3x minus 1. Now what you do is group the like terms, students. 2x minus 3x is equal to negative 1 and negative 1. So I have grouped the like terms. Okay, so positive become negative and you will get negative x is equals to negative 2. So now x is equals to 2, because negatives on both sides gets nullified, right? As per the rules of transposing, and you already know, if familiar with that topic. So your final answer, x equals to 2. Students, now we will move to the assignment section, students. Your assignment for this is assignment chapter 8, topic functions. Okay, assignment is chapter 8, topic functions, page 284. From page 284, question 1 AB, question 7, 11, 15 and 21. This is your assignment for today. Hope all are fine. Have a fine day. Good day to you all. Okay, take care. Bye. See you.